Hello, Internet. Recently, I've started streaming on Twitch, and this is, I guess, one of the VODs from that. So this is us working on Minefield, which is an older project of mine. The idea is a Minesweeper-style game board. This is just the beginning. There'll be more of this. And if you want to keep up on some of the stream things that I've been doing, I'm doing that over on Twitch. So there's a link in the description that you can go and check out. Otherwise, I'll leave it here, and this will just be the VOD, I guess. So hopefully you enjoy it, and we'll be experimenting with this a little bit more in the future. So if this is something you like, or you have some suggestions on how I could improve that, let me know. But other than that, here you go. We could do some game stuff, because why not? Yeah, let's give that a shot. So I'll come back to our GitHub Action stuff. I'll probably have the container stuff pushing and working. I think we're in a good spot. We have it building, and the build seems to be fine. So I think the only thing is storing it somewhere, and I just need to do more research there. And I don't think it makes a lot of sense for us to sit here for an hour or two while I do that. So we're going to do something else. Right, so we can close that. Let's see. What is that? That overlays was the project for stream overlays. So we can do stuff like this and actually get cubes over stuff. There's a video of that on YouTube. Let's see. OBS overlays. That's the same project. It was just broken in that version. Let's see. We had our platforming thing blocked. I don't know what I want to do. Not sure. I kind of want to just like build a full game and just do that. Let's do Minefield. So if you're not familiar, Minefield is an old, I guess, yeah, it is kind of old at this point, but it's an old game that I made like 5 years ago. And it worked like Minesweeper, but instead of you having to clear the entire minefield, your objective was to get from one point to another point without stepping on any mines. And so you revealed things sequentially by moving throughout the maze effectively, instead of just revealing them on a grid. And so you could actually kind of move through the place, but you could only reveal things adjacent to you. So you had to move to nearby objects. And so I think this should be something that we can build fairly quickly. I'm going to do this, and we're going to change our thing. Building Minefield mobile in Unity 3D. Sure, building Minefield in Unity 3D. Why not? We can get rid of these project settings. Those don't need to be there. Whoa. All right, there. Cool. That's all good. Let's create our basic stuff. So we'll just do scripts. This isn't the right version of Unity, so we're gonna just get rid of it and restart. All right, great. Let's switch up to 2019.3.11 F1. Sure. It's gonna get mad at me and say, do you really want to upgrade? Yes, sure, why not? That should be fine. Let's see. Game development. What? There. And programming and software. Cool. All right. Figuring out Twitch. It's fine. For some reason, upgrading a brand new project takes more time than just recreating the new one. I don't know why, but we'll sit here for a while. So basically what we need is we need a grid of tiles classic Minesweeper stuff. We just need to build that. And then the difference is just how you move through the game and what your cursor effectively does. And that's really the only difference. I intended it as sort of like a mobile thing because it was easier to do on mobile. So that's what we're going to be targeting and hopefully building, is just an easy way to do this on like mobile phones. Because I always found doing Minesweeper, especially in like the more difficult settings, harder because it didn't fit on your phone screen. And so this was sort of an attempt to make that easier because you kind of knew where you needed to go. I always had you start in the top left and move to the bottom right. So you just needed to cross to the same thing. And it didn't matter how big the grid was because you only cared about what was around you. You weren't trying to clear the entire thing. So we'll try that and see where things go. So we have our scripts folder. Let's create a resources folder. This might be a mistake. Resources means something special in Unity, so that's... Oh. What? We haven't even written code yet and we already have compile errors. Okay. Wow. Let's see. Package manager. Can I just update it? Oh, what? Where did you go? This. Up to date. It's up to date. Great. But it's broken. I don't think I can. Can I play my game? Oh, I can. Okay. Just a runtime error then. Great. Cool. Okay. That's gone now. Fixed. Okay. Let's just start building this. So let's make our game board. I think that's probably the easiest thing to build. So we'll just do game board. I don't think we need an entire folder for this, but we're going to do it anyway. Game board manager. I suppose. Don't know what I'm doing as far as naming goes, but it'll work out. Namespace. Do I want to start namespacing things? We'll skip that. So we need a board, which is going to be public. How do we want to do this? We want it to store two things. Does it need to even store two things? No, it doesn't. We're just going to create a private set of booleans. So a 2D array of booleans. This is going to store bombs, whether there's something there or not. And so with this, we can just do private bool of bomb locations, mine locations, mine grid. I don't know why I used a period to end that line. I'm doing really good so far. This is great. So we have this. Let's also public int width and public int height. This way we can make a separate height and width. I don't know if that makes a lot of sense, but we'll see. So, all right. So we have a separate height and a separate width. What we want to be able to do is be able to customize how wide and how tall something is. And so if we can use this, we can actually trim them both separately. I don't know why I spent that much time describing that, but there we go. So new bool width and height. There's our initialization. They should all initialize to false, but we're just going to do that anyway. So int x equals 0, x less than the width. Whoa. Right. And this should be y. And so we just want to set all of these equal to false. That's not how you do that. I don't think. X and Y. Maybe there's a better way to do this, but for now it doesn't matter. Like, this is not a slow part of our game, and it's like the initialization part of the game. So the only time we would need to improve this is if the loading times were bad or slow or like not good enough. And I don't see that being a problem. This is not going to take a long time. So even if there's better ways to do this, the advantage would gain probably isn't that great, and this is fairly readable. You kind of understand this pattern, at least I do. So keeping it this way hopefully makes it a little bit nicer. That's a mistake though. There we go. So we use height and width, fill our array, and that should be it. Now we just need to actually draw things. So there's another thing we actually need to be able to do with this, and that's going to be retrieve the value of these things. So public int adjacent mines. Calculate adjacent mines will do. And so we're gonna, I guess, provide int x and int y and use those as sort of our coordinate system. And so this sort of gives us a way to say how many things are adjacent at this position. And so how do we want to do that? I'm not sure. Like, the easiest way, I guess, is kind of gross. We could do it with 8 lines of just add if or just has mine x minus 1, y, etc. And if we get these, we just add 1 to whatever our value is. That could work. Maybe that's the best way to do that. And then we just need to implement this. Whoa. Why can't I generate a function for that? So I guess we want int adjacent mines equals 0. And then adjacent mines plus equals has mine that if it does, then 1, otherwise nothing. And we can just do that 8 times. Kind of gross. We can cut the code down, but I think this makes some sense. Invert conditional. There's still no generate function for that. Why isn't there a way to generate a function for that? That's kind of annoying. Oh, because it hasn't compiled yet. That's why. There. Nope. All right, still can't do it. Well, we tried. Public bool has mine int x and y. And so the reason we're adding this has mine thing in the first place, instead of just trying to index into this, is because we can't just index into this. If x is less than 0, or x is greater than or equal to the width, we want to return false because we're outside of our grid. And we want to do the same thing for the y. So if y is less than 0 or y is greater than or equal to our height, we're going to also want to return false. After this point, then we can just index into the mine grid at x and y. But we do need those checks to make sure we're not falling outside of the grid. It saves us from having to do all of that multiple times inside of here, and that just gets gross. This isolates it and makes it all nice and happening in one spot. So we have like distinct things doing distinct actions. Here, we're gonna run through this. One more, there we go. This is gross, but we're gonna make it work. There should be 2 of these and 3 with plus. because we should have one less when they're equal, and this should be minus and plus. The only reason is because the center one is us, so we don't need to test that. That one we don't care. If it is a mine, then you lost, and if it isn't a mine, then it wouldn't add anything anyway. So we're gonna ignore it and pretend like it's fine. So we're gonna subtract, leave it the same, and then add, and then do the same here. So -1. That can stay the same, and then add 1. That is gross. That's really gross. I don't like this at all. Okay, great. So we have this. Let's actually add some other stuff. So we can now calculate how many things are adjacent to everything. When we're talking about building the tiles, this should provide us a way to do that. So we should actually be able to actually build things. What we want now is something. We want, I guess, to add tests for this. Wasn't really where I wanted to go. Jason. What word was I spelling? We'll just ignore all of this. They're all wrong. There we go. Fixed. Cool. Great. So that should fix that. And now we should be able to actually compile this and actually get some things working. So let's do that. Add some tests here. Do we want to do it in the scripts? Let's do it in a separate tests folder. And so we're going to create, where did my testing, oh, it's over here, weird. That's not where you're supposed to be, but sure. Edit, tests. That's not how you spell that. There. And we also are going to need our assembly package thing. So we need an assembly definition to define our objects so we can include them into our tests. So this will just be Minefield, I guess. Can I not? Wait, is that not what I think it is? Okay, there it is. I was confused. We shouldn't need to change anything here. It should be fine. We just need to go into this edit tests and find the other one, and then also include assembly definition references. I don't think we want that. Do we? Okay. This can go away. We want it here. All right. Cool. There's our new test. Cool. All right. So now we should be able to actually write things. We'll apply that and go in here. That's still spelled wrong. What? Let me rename you. There. And edit tests. Okay. Unity's being a little bit weird, but we got there. Apply that. And cool. All right. Maybe? There we go. All right. I was thinking about compiling, and it finally got there. Let's do our game board. And so we should be able to create a test here. So we're going to not do that. That's a behavior. Let's see here. Testing, C# test script, game board tests. And I realize at this point we've also made this game board manager a mono behavior. Let's get rid of that and just make this a game board manager So this is a constructor now that accepts an int of x and an int of y. So you just create your game board like this. And so we actually need to, not x and y, but width and height. And so we can do this dot width equals width, and this dot height equals our height. And that should pull all of that in, and then we actually should be able to use this to do that. We don't need too much else going on. I'm going to make these private with public getters, just because our board doesn't handle resizing. So we shouldn't allow resizing if we can help it, and this will give us a way to prevent that. So we'll just use a lambda here and do that. All right. And now, by removing the mono behavior, it should be easier to test. Unity mono behaviors can't be instantiated like normal objects. You need to do all sorts of other stuff, and that's just annoying. So if we get rid of them from critical things, it becomes a lot easier to detangle those objects from the rest of Unity. And that just makes writing tests a lot easier. We can still include that inside of mono behaviors. There's nothing preventing us from doing that. But we're just separating them and making it a little bit easier on ourselves so that we can actually distinguish what's supposed to happen here. We don't need that test, but this one, we're going to want to create just a really basic test. I think default board is empty test. And so this test is just going to do var manager equals new game board manager. We're going to do a 3x3. For testing, this should be ideally what we need, because we can test at 1, 1, which will be the center of this. And we should hopefully only see zeros around it, but we shouldn't go off the board. So let's see. Var manager, cool. Assert dot equal. I don't, what? I'm slightly confused. Where did my NUnit stuff go? That's a little weird. We're just going to do assert.r equal. I'm pretty sure I know what we need. We're just going to guess. We want to assert that calculate adjacent mines at 1, 1 is equal to 0. So we're expecting 0 and expecting that to be 0. And so we should be able to just compile that, hopefully. It'll yell at us if I typed any of that wrong. But we get our test, null reference exception. Oh, that's from a completely different project. Great. So we run this, get our test to run, and it passes, which is good. It doesn't really tell us too much because it just passed. But we should be able to set this to say 1 and see this fail. Typically failing tests are useful and passing tests are just annoying. In the fact that like you have a test, but if it's only ever going to succeed, that looks great on paper and it makes your metrics look all nice, but it doesn't actually help you as far as software goes. Ideally, you want to make sure that these fail when the case should fail. And so by doing that, we just actually asserted that like it will only pass if it's equal to 0. So there's one of those. We can expand this a little bit more. And so we're probably going to write a bunch of tests here. We have this really gross thing happening here, but we should test each of these functions and also probably test the width and height to make sure that they're assigned. Those are easy enough to test. So we can do like test width is assigned and we can just do manager.width is equal to, say, 10. And we'll just say create a 10 by 5 thing. By doing it separately, we're actually removing the fact that we might mix them up and assign the width to the height or something like that. But we can do this and then do the same thing for height. So height property is assigned. This should be 5 and should measure the height. Again, mostly just to test, we're going to be relying on those to be accurate because that's how we actually read information about our game board. And so if we can't read them and trust them, it's not going to be very helpful for us. So we're going to need some help there. Default game board is empty. That's testing our game board is empty. Now that we have all of this, everything should be good. We just need to actually finish up testing this. We're going to, because this is such a critical part of what we're building, we actually need to do that. So we're gonna make sure we test this. Has_mine is probably the next thing to test. But first we actually need to be able to assign things inside of here. So one of the advantages of building tests is we're figuring out what's missing and what isn't. So we have no way to read our mine grid. There's no way to assign anything there. There's no way to read it. So we are going to do a public void insert mine at int x int y. And we're just going to do mine grid xy equals true. This obviously doesn't always work. We can still go outside of our boundaries. So we're just going to take that, test here. And what we can do is refactor this out, or I guess not. We can go down here and do public bool is in bounds. Let's do a pro. I guess we can make that public. Public bool is in bounds of x and y. And we can return true unless it's one of those cases. And then we can remove all of this stuff and with just an is in bounds of x and y. And that kind of shrinks this a bit. So insert mine, if it's not in bounds, that's what we care about. So if it's not in bounds, return false, otherwise return the mine. If it's not in bounds, then this is just going to return and not do anything. So it's a no-op if we're out of bounds, because you can't insert a mine that wouldn't exist in the first place. Otherwise, we're just going to assign it to true. So we should be able to build this and rerun our tests. Everything's still passing, so we're fairly good. Next thing, I guess we can test is in bounds. What's it called? It's called a fact. That's an XUnit thing. Theory. That's what they're called. We're going to create a theory. Public void outside boundaries returns false. Int x int y. Cool. And so we just need to create this game board manager again. And what we're going to be doing is asserting that we are out of bounds for any of these things that we provide. So we need to provide inputs that are outside of boundaries, but we can do that. So manager dot is in bounds of x and y, and we're expecting this to be false. So assert it's equal to false, and then we just need to actually provide things. I believe this is a data. I don't remember. Let's go figure that out. So NUnit theory And they provide data points. That could be annoying. Can I do data point? Data point. Let's try and see what happens. So data point, and we should be able to provide, say, like -1, 0. And we'll see if it likes this or not. And this should be 11, 0. And we can do the same for the y values. So go inbounds here with like 5. This can be 4. And we'll do -1 and 11. Again, actually 10 is probably a better test. It's the edge case, so we'll see. But that should hopefully at least tell us what's happening. And so these should map into the input types here. I don't actually know if this works. Nope. All right, let's try data point. Maybe I spelled it wrong. Nope, doesn't know what that is either. Well, we tried. Okay. For an example, you see theory. Okay, that's kind of annoying. So we would need a separate class for this, right? Am I reading that right? That's annoying. Yeah, I'm not sure, but I guess we can do that. That's not too big of a deal. So we need data points. So we are going to do this. Do a data points attribute and create public. How do we do this with an X and a Y though? I don't actually know how to do that. There's no example here of 2 arguments. Okay. Parameterized tests. Maybe that'll help. Nope, that's not going to help either. Pairwise, that sounds about what we want. Okay, this could work. We can make this work. Yeah. So we don't actually need that. We can just do test and pairwise. And then here we would do values and assign them that way. So we do values and then in brackets, whatever. So we'd want -1, -10, 10, like that. And then values of -1 and 10, like that. And it doesn't like, doesn't like lowercase values. There we go. Those should both go away. Yeah. And then we should be able to run this and get 4 different tests because we had 2 values in each. So combine them all and we get like 10, 10, -1, 10, etc. The only downside with doing that is this causes them all to be outside because it's doing a cross product of them. If I put 0 in one of these, I guess I could do it for one, but I can't do it for both. If I do 0, 0, like if I do 0 here and then 0 on the other side, we'll have a test that's testing for 0, 0. And that should actually succeed. So that's a little bit less nice. But for this, we can do that. It'll test whether things are inside outside the boundaries. Inside boundaries returns true. Test. we'll add test to the end of our functions just so it's a little bit easier to understand. And that way, yeah, we'll see. All right, inside, we'll do 0 and 9, because those are, again, the edge cases for this. And we'll also just throw in a few other values. So 0, 9, 5, we can test 7. Doesn't particularly matter what we choose. It's just going to pair all of these together, and so we should get 9 tests here that get run, and then we should be able to actually tell what's happening. That's not an edge case because we only are 3 wide. Let's make it 10 wide. There we go. So is in the boundaries should be true, and so with this we should see a whole bunch of tests pop up. Yeah, there we go. So there's a whole bunch of things that we're going to run tests for, and they all pass, which is good. So now we've tested our is in boundaries, which means that we're pretty sure that actually works. That actually does what we think it does. Has mine, we haven't really tested. Calculated adjacent mines, we've kind of tested, but not really. Insert mine, haven't tested that, but we'll need that to test the other ones. So we'll do has mine next. So test public void mine at mine is detected when present test, I guess. We'll figure that out. Var manager, new game board manager. And so I'm noticing we are doing a lot of this manager thing to initialize the manager. I think we can do a private, not that, game board manager, and create a manager here. And we're just going to leave that empty and do a setup method like this. I don't know if I'm not familiar with Nunit, so we're making this up. But public void setup tests, and this will do manager equals new game board manager of that's 10 by 10. So the downside with this is now we've hard coded all of our game managers to be the same size. So we can leave it using a custom manager for the width and height, but everything else we should be fine here. We should be able to just do 10 by 10 and not have too many issues. And so we can actually just delete these because our manager already exists now. And so now our tests are 1 line long, which is great. So we actually need to make that work though. And so in order to do that, I think, well, I guess we'll find out. Setup attribute doesn't exist. So we need to fix that. Nunit test setup method. Let's see. The setup attribute. Setup, teardown. So there's 2 ways that things can happen. They can be set up at like the class level. So when you create your class, things can be created, or when you create a specific test, things can be recreated. I want to double check, maybe either static or instance methods, and may define more than one of them in a fixture. Normally they're only defined, yeah. We define a setup class. They can be async. So there's a one-time setup and a one-time teardown. I think we don't want those. But this should be fine. We just need a capital U. Cool. And so if I rerun these, they all still pass. But we actually are defining it up here. And so we don't really need to do all this extra stuff to make this work. So mine is detected when present. In order to do that, we actually need to create a mine. So we're going to do manager.insert mine. And we're just going to insert it at 0, 0 because we can. And do has mine at 0, 0. And we wanted to assert that that's true. So assert are equal true has mine. And we also want to do a test for not detected. Mine is not detected when absent. There. So we just don't insert the mine, and we're asserting it's false. And this should also tell us if that setup is going to work for us or not. But it seems like we're good still. So that's nice. Everything seems to still be working. Great. Let's see here. Mine is not detected when absent. Mine is detected when present. Cool. Let's do... what else? That should be our has mine, right? So has mine now detects when it's present or not present. We don't detect, or we don't test when it's outside the confines of it. So I guess we can test that too. Inbounds. So we'll do that same pairwise function. So outside bounds, mines do not exist outside of board boundaries. Kind of a long mouthful of a name, but it gives us enough information that we can actually kind of tell what's going on. And we're just running has mine here instead of the is in bounds function. And so those should all return false and give us some more information about everything that's going on. And so there we go. We have 26 tests, and we've done that in only a few minutes. Probably more than a few minutes, but not that long of a time. And it's actually giving us some like actual confidence in our code that it's actually going to work. And I haven't clicked play to actually test this. We don't even have a mono behavior, so we can't click play to test this. But it's kind of giving us that nice ability to actually see that our code is doing what we expect it to. And we actually have all these concrete things that we're testing without having to create scenes for them or do any of that. So it's making it hopefully a lot easier for us in the future. Calculate adjacent mines. This is going to be harder because I don't have a good way to like write these tests yet. So we're going to just wing it. Mines are detected in adjacent tiles. Sure. This is probably going to be a little bit more complicated. Let's see. I think there was a pairwise function here. There's also a sequential function. How does this work? Oh, okay. That would be really helpful. We can do that. Combinatorial. What does that do? This looks just like the pairwise function. It's doing a similar thing. Okay, I don't know the difference. I'll figure that out later. But the sequential thing we could actually use for this, maybe. So mines are detected in adjacent tiles. We're gonna make that a test. And so, actually, in adjacent tiles is probably not the best. In diagonally adjacent tiles, sure. And so we actually want to do a sequential test. And so I'm going to detect that there is one object in a circular area around me. So we're going to do values like this and do 0, 0, 2, 2. This will make sense in just a bit. And then we want that to be an int of x. We also want another set of values of 0, 2, 0, 2. And so I've sort of created a spiral around 1, 1 that touches all the diagonals if you count those as like separate pairs. So we'll go 0, 0, 0, 2, 2, 0, and then 2, 2 as our coordinates. And then we should hopefully be able to use that as a way to more easily test this. So we should see 1 as each of these errors. So if I do a manager.insert mine at xy, we'll insert it in each of those diagonal corners. And then we want to assert that we're equal to 1 at the manager dot calculate adjacent mines of 1, 1. And so that should hopefully test all the diagonal adjacencies. And then we can also test our cardinal adjacent tiles. That's probably not a better name for this, but we'll do, let's see, 1, 1. And then, so 0, 2, and then we want this to be 0, 2, and this to be 1, 1. And so the 1 will test in each of those directions. I'm separating these just so that if I try to do anything special with the diagonals versus directly adjacent tiles, we have something that'll tell us whether that's failing or not in that specific case. Otherwise, it could get a little bit confusing if we just had all 8 test cases. Plus, we're just throwing random numbers here, and that's already confusing. So minimizing that is hopefully going to make this a little bit nicer to read and less confusing. So that should be all of those. The other thing I want to do is just move this. Default board is empty. We're going to move that down with all of these other calculate adjacent mines things. That should hopefully give us a little bit more cohesive test written stuff. Words are hard. Cool. All right, so those all passed. Now I think we just need to, I don't even know. Now that we have that though, we have all of our mines tested, and I don't think we need to test off the board. We could, but it should be fine as it is. The insert mine has to work because that's covered in all of these other things that are testing for mines to exist. So if that didn't work, all those other tests would fail. And so we know that. So we should have pretty good coverage over this game board manager at this point, and should actually be able to rely on that as a way to build all of this. So next, we actually need to turn that game board manager into something we can use. And so we're going to do game board manager behavior. And so this is a Unity wrapper around this. So int width and int height, we'll set those equal to 10 by default. And so now that we have those two, we should be able to also create our game board manager. So private game board manager, like that. Start, we'll do manager equals a new game board manager with our width and our height. And then we just need to initialize this somehow. There shouldn't be any updates required for this yet. It's mostly, this game board manager is just going to represent the state of the game board to everything else. So there shouldn't be too much required here. There's probably going to be a lot of changes that we're going to need to make all of this work, but we're not there yet, so we can ignore it. So here, we have all of this. That should be fine for now. All right, so that'll create our game board manager. Next, we need to actually do something with this. So what's the best way to do that? Private game object array. We're going to create a double array of game objects. This might get a little bit gross, but we're going to do it anyway. And this will be our game board. And so with that, we can take our game board and create a new game object array of width and height. We could read it from the manager, but we don't need to. It should be the same regardless. So we'll just create both of those, and then we should get rid of that quote and be able to do something like, I guess, initialize game board. What happened to generating functions? Why isn't that a feature? Seems to not work. All right, so we can initialize our game board, and for that we're just going to do our loop again. So this thing. But instead of modifying our board, we're actually going to instantiate game objects. So instantiate board tile template at vector3. This transform some position. We'll figure out that later. Some position, and then the quaternion dot identity. Transform dot position. For the position, let's do vector3 dot right times x plus vector3 dot. We have a choice to make, I guess. Do we want this to be on the xy plane or the xz plane? So if it's xz, you'll look down on it. If it's XY, you'll be looking like forward, like you're looking at your screen. And let's do up times Y. That means we can do like vector 2s, and it'll make some sense. So that should make most of that make sense. This is going to be our game object, so we're going to have our tile. And so the tile is going to be put in our game board, so we're going to take our game board at xy and set that equal to the tile. And then what we can do is fire events from this game board manager that are picked up by this game board manager behavior and modify this. And so this will be like our view of what the game state is. Everything is going to operate on this object though. And so we'll pull this game board manager in and actually work on that. And then the behavior will take those edits that we make and render them so you can see them. And so here's this. We have our game board. There's our tile. It all should be good. This should actually be creating things now. The only problem is this function is massive. So we're going to hopefully make this a little bit nicer. I'm going to remove this transform.position for now. I actually am not super sure I like that in the first place. Just because then it's tied to this and can move, and that's weird. So we'll just do spacing. So this is going to be a new thing that's just going to help us tweak how far apart everything is. So public float spacing. We can rename that. So tile spacing. There we go. And that renamed everything there. I used the F2 button to do that. So now we just need tiles. Let's create a cube. Sure, that'll be our tile. That's easy enough. Board. There we go. So there's our tile. We can get rid of that one and create this. We need to attach our board game manager behavior. It's not compiling. Board tile template. Oh, because I didn't create it. There we go. Public game object. There we go. There's our template. Doesn't like the quaternion identity. I think that needs to be lowercase. There we go. Okay, cool. So let's rename this to Game Manager so we actually know what it does. And then put our board game manager behavior. It's already on there. We don't need to do that. Let's grab our board tile, assign that, and give it a spacing of 1.1. Just so things aren't all attached to one another. This should give it a little bit of breathing room. And so if we run this, now we get our game board. Cool. And so the downside of the way this is working is up and right are the two directions we used, which means the bottom left is our 0, 0, and the top right is actually our maximum value. I don't know if that makes sense, but that's just the way we've done it, so that's how it's going to be. Because we're just doing rendering to get this to all work, it should be fine. The only thing I don't like is this. I'm going to take this out and create a public vector3 get tile position. We're going to give it an X and a Y position and turn that into our position. And so the advantage of this, doing it this way, is we now have a single spot that is going to determine where everything is put. And by doing that, it means like if we need to adjust our camera to figure out where to actually find this thing, we can do that. And so I just need to have my camera call this and say, I want to look at tile position 10. We can actually figure out what that is and move the camera to that position to actually look at it. So hopefully that makes things a little bit nicer for us. And it makes this function less awful. So that's always good. And so we have basic tiles, not too much to show, but it works, and that's sort of the important thing. We can tweak how all of this stuff is rendered later. That isn't really the hard part of this. It's more figuring out how all of the other stuff actually works. So I think what we're going to do is try to assign something to this. What I'd like to do before ending this stream is actually be able to assign values to each of those tiles and be able to generate mines throughout this field. So how do we do that easily? We could just use some like Perlin noise, I guess, or just like random numbers. Why not? It doesn't really matter how many mines we generate right now. We don't need this to be a fair generation or even a completable generation. We just need to do that. And so we can. Let's do initialize game board, blah. We're doing all of this before we generate all of that. Let's do a pre-loop, I guess. Like that, I guess. And do game board dot set, not set value, manager. That's the one we want. Manager dot insert mine at X and Y. but we only want to do that if random.value is greater than 0.9. So random.value returns a random number between 0 and 1. So this should detect about 10% of the time and create a mine for us. And so just so we don't get stuck looking for things that don't exist, we're going to do a debug.log and do inserted mine at x y. We're going to use C# interpolated strings to do this. That's sort of what it looks like. You use the $, and then you can use brackets to kind of insert things from the current scope into your strings, and C# will figure out how to do it for you. So this should get us a set of random mines. The problem with this is the game board knows absolutely nothing about those mines. So what we'll need to do in here is do tile.addComponent. There we go. And we need to add an object onto this. And so we are going to add some sort of tile manager thing. I'm going to ignore that. that error is I just created, so we can ignore that. So we will have a tile behavior, and this will be a public int adjacent mines and a private text. Doesn't exist. Great. Unity engine.UI.text. Text. There we go. We can just use Unity engine.UI and drop this. And so this will be our text. We need to actually figure out what that is. So we're going to do text equals get component in children, I think. And we want to find text. Capital T. Capital T. There we go. And so that will actually be our text object that we're going to render things into. And once we have that, we can just set the adjacent mines. For testing, because I don't have all the events and things set up that I want for this, we're going to do it in the update. Not the greatest, not needed either, but we're going to do it because we can. So we're going to do adjacent mines equals, or sorry, text equals adjacent mines. String. We'll just do that interpolated string again because we can. Adjacent mines. There we go. Not like that. Text.text, I believe. I could have that very wrong, but we'll find out. Seems to work. So we're going to add the component of a game board or tile behavior. So this will be our tile behavior, like that. We just added that onto the tile that we created. So those tiles are just going to be graphical things, and they'll have some sort of text in them. We're going to find that text component and then use that to assign a number to it. This way, we don't need to do any other fancy stuff. And those can just be graphical things. They don't need to have a lot of code attached to them. We're going to do that and inject that automatically. And so we're just going to do tile behavior dot adjacent mines equals manager dot calculate adjacent mines at xy. Maybe? There we go. Cool. So all of that's gone, and we've created this thing. So now we should be able to actually open up this tile again. And so this side is the front. At least that's what I'm electing to call it. And so we're going to insert a text object inside of our, they're all going to have canvases. That could be gross. We may want to not use text in the future, but for now it should be fine. We're going to do a world space canvas. We don't need an event camera, and I don't think we need this either, but we can leave it all for now. Let's see. That's all huge. Let's not do that. Let's do 100 by, that's position. Let's do a 1000 by 1000 and 1 by 1, right? Let's actually scale it to be the right size. And then we can just move this forward. So it's in front. We probably need to rotate this. I imagine it's backwards, but that'll be fine. Our text is going to be 0 by default, just so we have something there. The only problem is it's too small, so we don't get anything. Oh, we are getting something. It's just backwards. Okay. Interesting. I hadn't expected that to work, so surprised. But there's that. Oh, I forget how to do this well. What? Okay, so it automatically adjusted my size when I clicked that. That's weird. 32, it doesn't like that. 24? Sure, and then we'll just shrink that down a whole bunch. 0.1. Too big. 0.05. Still a little bit big. We'll do 0.3. And we can add our own text later, our own fonts, and make that actually look good. For now, we don't care. It's literally just there so that we can test things. So that looking good is probably just a waste of time. We assigned everything there, so we can drop that. It should still be assigned, so we should be able to apply this, and there we go. There's our game board. We just get random things everywhere. It's impossible for me to know which ones are mines and which ones aren't without looking at the console, because we actually don't show mines. So some of these numbers are mines and some of them aren't. I don't know which one's which. They're just there. But there's that. So now we have all of these mines that we can kind of play with, use them to whatever we need to do. But I think that's pretty much our game board done, like working in its most basic state. We can probably improve this more and make this a lot better. But I think that's a good starting point, at least. Let's see here. So we had talked about showing mines. I think that might be something that we actually want to do. So tile behavior add component that. We want to also do tile behavior dot is mine equals manager dot has mine at xy. So if it's a mine, we want to know that inside of our tile behavior. So we're just going to jump over there. Public bool is mine. And then if we don't even need it there, we can do it in here, right? Is mine question mark. Okay, I was kind of reaching for that one, but we can just do this and do. So is mine, it will be a asterisk, I guess. Otherwise, it will show the number of adjacent things, and this should actually help us visually determine if what we're getting in our output actually makes sense. So we should be able to just restart this. And so those have 2. That makes sense. Those will have 1. Those are 2. 2, 2. 2, 2, 2. Cool. It all seems correct, which is good. It means our tests align with our expectations. All of our tests should still pass. I don't have any play mode tests, so we can't run those. I've never really played with them, so I don't really know what the advantage of a play mode test would be over these. But we have them. So I guess we now have a game board that we can use. There's some downsides to our implementation, though, and some things that we can improve. We have a whole bunch of weird things going on here. Like, we're storing booleans. In here. We're storing booleans here. There's no way for us to tell whether a tile has been revealed or not. We don't currently handle that. There's probably an advantage to doing that. Whether that's handled in here or somewhere else is a different decision. I'm leaning towards something else handling visibility. So, like, we don't need to modify this class at all. We can just leave it. But maybe this has some separate dependency, or these tiles have some separate dependency that they pull in that says what tiles have been revealed, because I only want to reveal tiles that are adjacent to your cursor. That's sort of the intended way to do this. So I guess we can play with that. I'm going to leave it here, though. I think this is probably a good amount of progress, and then I can come back to this at some other point. So yeah, I think that's pretty much it. So thanks for everybody that tuned in and watched, and hope you all had a great weekend. So I'll probably see you next weekend, and we'll pick this up some more and do some more work on it. If there's other projects you want to do or have ideas of, send me a message on Twitter or Discord or whatever, and I'll take a look. But otherwise, yeah, that's pretty much it. So thanks everyone for tuning in, and I will see you next time. Bye.